This is how a large language model actually works, not the myth, not the keynote version, not the part where someone waves a hand and says, it just understands language now, like that settles anything. The real version is less magical. A large language model works by learning patterns in language at enormous scale, then using those learned patterns to predict what token should come next. That is the core. Still true, still the whole scandal. But now let's open the machine. First, language goes in. Not as meaning, not as thoughts, not as the glowing poetry of human consciousness, as tokens, chunks of text, broken pieces. Units the model can actually process without having to become a person. Those tokens are converted into numbers, because inside the machine, everything has to become math before anything can become language again. Then those numerical representations move through layer after layer of the model. At each layer, the system transforms those representations, mixes information across the sequence, and figures out which parts of the input matter most in relation to other parts. That is where attention comes in. A word at the end of the sentence may depend on a word near the beginning. A pronoun may depend on a noun from earlier. A phrase may completely change meaning because of one miserable little modifier buried halfway through the paragraph. The model has to track those relationships. That is what the architecture is for. As the tokens move through the network, the model uses its learned weights, all those trained numerical settings, to shape how strongly patterns connect, how features activate, and what possibilities become more likely. By the time the signal reaches the output, the model produces a probability distribution over what token should come next. Not one answer at first, a field of possible answers. The next token is then selected or sampled based on those probabilities, and once that token is chosen, it gets added to the sequence. Then the whole process happens again and again, one token at a time. That is how you get a paragraph, a poem, a summary, a legal disaster, or a suspiciously competent email. The machine is not leaping to the finished answer in one burst of synthetic revelation. It is building the response step by step, recalculating as it goes, using the full context currently in view. That is why large language models feel so strange, because the mechanism is simple in concept: predict the next token. But at scale, with enough data, enough parameters, enough layers, and enough training, that simple mechanism starts producing language with structure, style, continuity, and the deeply unsettling appearance of thought. People hear next token prediction and assume that sounds too small to explain what the model can do. Unfortunately for everyone, language is doing more work than they think. If you get good enough at predicting what should come next in human language, you start reproducing logic-shaped outputs, reasoning-shaped outputs, empathy-shaped outputs, expertise-shaped outputs. Not because you became human, because human language contains the patterns of all those things, and the model learned the shape of that surface well enough to imitate it at speed. So how does a large language model actually work? It takes tokenized text, turns it into numerical representations, processes those representations through many layers using learned weights and attention, predicts the most likely next token, adds it, and repeats the process until the output is complete. That is the machine. A token engine trained on the statistical structure of language, stacked deep enough and tuned hard enough to make prediction look an awful lot like intelligence, which is either an incredible breakthrough or a deeply elegant warning. Possibly both.